when they want us to simplify the square root of 80. And so if you're using your factor tree method here, you would say 2 and 40, 2 and 20, 2 and 10, 2 and 5. All right. So we're going to see what pairs up. We can take that out. So 2's pair up, so a 2 can come out. Another set of 2's pair up, another 2 can come out. 5 does not pair with anything, so it will stay in. You should have gotten C, which was 4 square root of 5. 4 square root of 5. All right, let's look at the next one. They want us to simplify this multiplication. So we end up with 5 times the square root of 3 times 6, which is 18, and x squared times x, which is x cubed. We can simplify this. So we know that we're going to have 3's that come out with this 5. So we have a 5 and a 3 on the outside. We have a 2 that stays in. And then let's look at our variable. The exponent here is a 3. So 3 divided by 2 is 1 with the remainder of 1, meaning that 1x will come out, 1x will stay in. So you should have gotten f, which was 15x square root of 2x. All right, 15x square root of 2x. And then the last one. It wants us to know which of the following equals 2/3. 2/3. You can eliminate some of them rather quickly. You can automatically see, like, square root of 6 does not have a perfect root. 27 does not have a perfect root, and you can't even reduce this guy. If you reduce this one, you would have like 2/3, but it's under the root, so that's not going to work. So it has to be one of these two. 9/25 actually has a perfect root. What's the perfect root of 9? And the perfect root of 25? That's not it. So how do we know that this one is it? We can reduce it first. What goes into 20 and 45? 5. Yeah, so divide top and bottom by 5. 20 divided by 5 is 4. 45 divided by 5 is 9. Those have perfect roots, which are 2 and 3. You should have gotten B here. B. Here. Pythagoras is credited with this theorem, although there is evidence that prior to him actually recording this theorem that it was used. It's based on right triangles. And so first let's talk about what a right triangle is and the pieces of a right triangle. A right triangle specifically has a right angle. That makes sense. Only one right angle. You can't have more than 2 right angles in a triangle because they only add up to 180, and that would be too many angles at that point. For a right triangle, you have some specific parts that are always just to a right triangle. The hypotenuse here, which they have labeled, is always your longest side. And so your longest side will always be your hypotenuse, and it will always be directly across from that right angle. That is your hypotenuse. The other 2 sides of a right triangle are called the legs of a right triangle. And the Pythagorean theorem actually describes the relationship between the length of those legs and the length of the hypotenuse. And so this is a formula that if you have not already used, you will use a ton in math going forward. And so it's one that you definitely need to memorize. If you look at the top of page 585, you see the Pythagorean theorem. This theorem states that if you take the square of one of the legs and add it to the square of the other leg, it will equal the square of the hypotenuse. And so this works for all right triangles, no matter what size, but it does not work for any other triangle, only a right triangle. So the sum of the square of the 2 sides will equal the square of the hypotenuse. So the first example they give us here is this triangle. Perfect roots. So, all right. So the Pythagorean theorem here says that if I take the sum of the square of the sides, it should equal the square of the hypotenuse. So I'm going to set this one up to look like this. 9 squared plus 12 squared equals C squared. All right. So what is 9 squared? 9 squared is? 12 squared is? There we go. All right, if you add those up, you get 225, which actually has a perfect root. Now I have solved for c squared. I want to solve for c. So remember when we were solving equations, we have to take the square root of both sides. So I have to take the square root of this and the square root of that. So c is going to equal, according to our rules, either positive or negative 15, right? Because we had a variable. However, we're talking about the length of a side of a triangle. It cannot be negative, right? So c here has to be 15. So my hypotenuse length would be 15 centimeters. So this is a word problem. A fire truck parks beside a building such that the base of the ladder is 16 feet from the building. The fire truck extends its ladder 30 feet as shown at the left. How high is the top of the ladder above the ground? They have told us that the fire truck starts or sits 10 foot above the ground. So we need to figure out this other piece. Now in this case, they have not given us two legs. They have given us the hypotenuse and one of the legs. And so we're going to fill in what we have and solve for what we don't have. In the same way, using the Pythagorean Theorem. We have 16 squared as one of our legs. We do not know the other leg, so we're going to write the other leg there. And we do know the hypotenuse, so we're going to put that there. Now in this case, 16 squared is 256. We're still looking for b. 30 squared is 900. Now we need to solve. We're going to use just basic algebra to solve here. We are going to subtract that 256 from both sides. All right. When we do, we get b squared equals 644. This does not have a perfect root. So if you plug this into your calculators, you still have to take the square root of both sides, but you are going to have to round. They rounded to 1 decimal place, all right? 1 decimal place, you get 25.4. So first, make sure that you can take the square root of 644. Right? When you put this into your calculator, you're going to get a number like this, and it keeps going. All right, let's talk about rounding, because I sometimes have issues with people rounding incorrectly. When they want you to round to 1 decimal place, that means your 10th, you have to look at the number to the right of where you're rounding. If that number is 5 or more, you will round up. 4 or less, you will leave it the same. So 7 is more than 5, right? So we're going to say 25, and we are going to round that 3 up 1. And that's where we're going to get the 25.4, all right? 25.4. Now, in this case, we did solve for our other leg. However, they want the total distance from the ground to the top of that ladder. And so we do need to consider this 10 feet. What do we need to do with that? What do we need to do? Yeah, we need to add it. It's 10 feet higher than that, so we're going to add that 10, meaning the top of that ladder is actually 35.4 feet above the ground, okay? Above the ground. So we're going to use the converse. If the side lengths fit into the Pythagorean theorem, then I know I have a right triangle. And we're going to see if these are indeed right triangles. How do you know if you have a hypotenuse? Well, you're going to assume that the longest side is the hypotenuse and then try to prove if it works. Hypotenuse will always be the longest side. So if you do have a right triangle, the longest side will work for this. So in this first one, the longest side here is 13. So we are going to assume that 13 is our C and 5 and 12 is our A and B. And we are going to set it up that way. We're going to say 5 squared plus 12 squared. Does that equal 13 squared? And then we're just going to do it. 5 squared is 25. 12 squared is 144. Those add up to 169. This 13 squared is 169. Yes. So you would say, yes, this is a right triangle. Okay, yes it is. And so that's all the converse tells us. We can use it to figure out if we have a right triangle. Let's look at B. For B, we are going to assume that 12 is the hypotenuse here. So we are going to say, well then 7 squared plus 9 squared should equal 12 squared. 7 squared gives us 49. 9 squared gives us 81. We're going to add those two. They equal 130. What is 12 squared? 144. These do not equal. So we would say no. Not a right triangle. All right. That's what our converse helps us do. All right, questions on that? So go ahead and try check understanding number 3. This is a physics problem, so you will do forces in physics when you get there as juniors. Two forces pull at right angles to each other. The resultant force is represented as the diagonal of a rectangle as shown on the left. The diagonal forms a right triangle with the two perpendicular sides of the rectangle. For a 30-pound force and a 40-pound force, the resultant force is 50 pounds. Are they pulling at right angles? All right. So it's a rectangle. You can assume that the side lengths are the same, opposite each other. Okay. So if the forces are pulling at 30 and 40, then that would mean, if I were to use this triangle that they have drawn for me, that one force is 30 pounds and another force is 40 pounds. Okay? And they're saying this is a perfect right triangle. Well, I can actually assume that this down here, I can just drop it down here, 30 pounds, right? And so I have this right triangle that is created. 30 pounds of force pulling one direction. 40 pounds of force pulling the other direction. And the resultant force going this way right here across the diagonal is going to be 50 pounds. All right? They want to know if they are indeed pulling at a perfect right angle. So we're going to set it up with the Pythagorean Theorem. 30 squared plus 40 squared equals 50 squared. Is that true? 30 squared is 900, right? 40 squared is 1600. 50 squared is 2500. Is that true? Yes, they are pulling at perfect right angles. All right, so forces work the same way if they're using a right angle to do it, which most of your force problems do use right angle trig. So look at the top of page 587. The Pythagorean theorem for forces with 70 and 60 pounds. Yes or no, are they pulling at right angles? a graph like this. So this is rather easy. If I want to find the distance between these 2 points, I can really just subtract, right? So for this vertical line here that they've given us, this vertical line, if I want to find those distances, I can really just find the distance between the y's, because it really didn't move left or right. Everybody see that? It just moved up and down. And so if I want to find those distances, I would just say, well, that's easy. That's going to be 3 minus a negative 2, because it went from 3 up here to negative 2 down here. Okay? And so 3 minus a negative 2, of course, add the opposite, is going to be 5. Okay? Simple. And then let's look at the horizontal line. Well, for the horizontal line, I just have to worry about my x's. My y's didn't change at all, right? And so I really just have to say, well, I went from 1 to 5. Distance is always positive. 1 minus 5 is going to be negative. I can probably do this, right? Distance is absolute value. So the distance between those is going to be 4, right? From 1 to 5. The distance between 1 and 5 is 4. So it's really simple when you have a vertical line or a horizontal line. But look at the middle of that page there, and they have created this triangle for us. Particular line from P to Q, and I want to know what the value is or the distance. I can actually possibly use the Pythagorean theorem by creating this right triangle, okay? And so this right triangle tells me, well, if I know the distances of my x movement and I know the distance of my y movement, then I can use the square root of those and figure out the distance of my hypotenuse, because that's what's created. And so that's where we get the distance formula. The distance formula says we'll take the x's, subtract those, and square it. Take the y's, subtract those, and square it. And then take the square root of those sums. And that will be the distance of your hypotenuse. It is literally the Pythagorean theorem. The distance formula is. So look at the bottom of that page. The bottom of that page gives us the actual distance formula. This formula here says, take the square root of x2 minus x1 squared plus y2 minus y1 squared. Well, what have they done? They've said, well, c is going to equal the square root of a squared plus b squared. A represents the distance between the two x's, and b represents the distance between the y's. And then you have to take the square root because the Pythagorean theorem solves for c squared. And so at the end of all of our c squareds, we had to then take the root. So the distance formula is literally just the Pythagorean theorem written out, okay, to find using x's and y's. So let's actually use it. Look at the top of page 592. Top of page 592. You can literally just use the formula. And so if I have my x's, this is my first x and this is my second x, right? And then this is my first y and this is my second y. And so I'm literally going to plug that in. I'm going to say, well, my distance is going to be my y's subtracted, and it doesn't matter what order you subtract them in. If you want to leave it as x2 minus x1, that's fine, but you're going to square it, plus the difference of my y's squared. And then you just solve it. What is 3 minus 1? 2 squared. What is negative 2 minus a negative 5? Make sure you change it to adding the opposite, so it ends up being 5 minus 2. It's going to be 3, right? So then 2 squared is 4. 3 squared is, which is the square root of 13. It does not have a perfect root. If I say round to the nearest tenth, it means I want you to put that in your calculators, okay? If I say leave in radical form, I want you to leave it just like that. In this case, they want us to round to the nearest tenth, so you actually plug it into your calculator and you should get approximately 3.6. This is the distance formula. It is literally the Pythagorean theorem written out using x's and y's. All right, so go ahead and try check understanding number 1. Check understanding number 1. So two things about lines. Sometimes you want to know how long it is, and sometimes you want to know where the middle is. The midpoint's very simple. So it's kind of based on a right triangle as well, if you think about it. So if I want to know the middle of my x values, right, I'm going to say, well, from here to here, where's the middle? Well, the way I find that is I average it. I add my two x's, and I divide by 2. You'll notice, to find the x value of your midpoint, you add your two x's and you divide by 2, right? Well, a point has an x and y, and so I also need to find the middle point for my y. I'm going to do exactly the same thing. I am going to add my two y's and divide by 2. I want the middle, right? The average of that point. And so if I find the average of my x's and the average of my y's, I will find the exact point in the middle on my line segment. All right, that's all you have to do for this one. So let's look at example 3. So for this, I want to find my midpoint. I am going to take my x's, 5 plus 3, add them up. Oh, -1 plus 3. Make sure we all have the same thing in our books, and I'm saying it right. -1 plus 3, those are my x's. I have -1, +3, right? And then I am going to divide by 2. And then my y values, I'm going to say 5 plus 0 and divide by 2. All right? -1 plus 3 is going to give me 2 over 2. 5 plus 0, 5 over 2. If it can simplify, you definitely want to simplify. So I would simplify that to 1. You can leave it as 5 halves, or you may write it as a mixed number. I will take either one of those as long as your fractions are reduced as much as they can be. A circle is drawn on a coordinate plane as shown, and they show you the coordinate plane at the left. The endpoints of the diameter are -1, 5, and 4, -3. What is the center of the circle? So first of all, by definition, diameter goes through the center. Hopefully you know that, right? That's lower school type math, or at least middle school pre-algebra stuff. You know the diameter goes through the center. So they have given you the entire diameter, and they want the center of the circle. Where is the center of the circle? There's a couple things they can ask using diameter. They can ask you for the length of the diameter, and you will use distance formula. They can ask you for the length of the radius. You could use distance formula divided by 2. And then they can ask you for the center of the circle, which we would use midpoint for this one. All right? So we're going to do it exactly the same. -1 plus 4 over 2. 5 plus -3 over 2. All right? And so we're going to get 3 halves and 1 there. 3 halves and 1, or 2.5 as they listed in the book. Or sorry, not 2.5, 1.5 and 1. All right. So pay attention to what they're asking for when they do this. They're giving you enough information to solve for it. They're not always going to ask for midpoints. Sometimes they'll ask for you to use the distance formula depending on what they want you to find. All right, questions?